This example is asking for the domain and range of the relation, and also if the relation is a function. So let's start. Domain. This is a graph, so remember, we're not going to have a bunch of numbers listed out. It's going to be with the inequality. Well, for my domain, remember we're dealing with our x's. And one thing that I like to do that helps some students is, let's box out with the x's. Well, where do the x's start? They start here at the -4, so I'm just going to draw a line here, and I know that it can't cross that line. So I'm only going in this direction. Cool. My arrow tells me that it keeps going on and on and on, so it's going to keep going in that direction. Well, what I have here, for my x values, I'm going to keep on getting larger because I have -4, -3, -2, -1, 0, 1, 2, and so on. The numbers keep getting bigger, so my x is greater than or equal to -4, where that graph starts. We're looking from left to right for my domain. Now let's look at our range. My range, those are my y's. Where does this graph start with my y's? Okay, well, looks like the top of my graph, the highest point is right here at the 4, and then my lowest point, well, I don't really have a lowest point because I have this arrow that keeps pointing down, so it keeps going down and down and down. Well, if I start at +4 and I keep going down, that means that my y's are going to be less than or equal to +4. So there's my domain and my range. My domain is x is greater than or equal to -4. My range is y is less than 4. If this helps you to draw out these lines and these arrows, make sure you do that each time until you really get the hang of it. Now lastly, is the relation also a function? Well, what do we have to think about when we're thinking, is this a function when we're looking at graphs? If you're thinking the vertical line test, you are thinking absolutely correct. Remember our vertical line test. Awesome. So anywhere I put a vertical line on this graph, if it crosses more than once, it's not a function. So if it only crosses once everywhere, then we're good. Well, if I draw, for example, let's say this guy here. Oop, that doesn't cross more than once. Only crosses once there, crosses once here, crosses here once, crosses here once, crosses here once. And anywhere I draw it, it's only going to cross once. So in this case, it's a function. Let's look at another example. Same idea, domain, range, and then also whether or not it's a function. So feel free to pause it and try it on your own and play it when you're ready. For my domain, I'm going to look at my x values. So I start over here at -3, and I'm only going to the right there. My graph's pointing to the right. Ooh, but this time I don't have arrows, and it stops, it looks like, right here at +2. So I'm between these two values here, between -3 and +2. I'm going to write a compound inequality. I'm going to start at -3, and x is going to be between that and +2. So there's my domain. A little bit different than the last one, but you guys can handle it. You've seen compound inequalities before. I know you can do it, I believe. Next, range. My y values. Well, here the highest point would be 4. The lowest looks like -3, so I'm between 4 and -3. So -3 less than or equal to y, less than or equal to 4. There's my range. And lastly, is it a function? Well, let's think here. Is this relation a function? Well, I gotta look at my vertical line test, correct? Gotta look at that vertical line test. If it crosses in any spot more than once, then it's not a function. Well, if I draw a line here, oh, crosses twice, not a function. And we're all done.